Before we begin today's debrief, we need to establish our coordinates. To the residents of Bend, checking the morning air quality. To the families and sisters, watching the waters of Witches Creek. And to the hikers currently navigating the Pacific Crest Trail near the Three Sisters Wilderness. This report is specifically for you. If you are watching from the Seattle-Portland-San Francisco aviation corridor, pay close attention. You are currently positioned above a systemic shift that the traditional models no longer account for. Right now, as you walk the trails 3 miles west of South Sister, the earth beneath your feet is doing something it hasn't done at this scale in a generation. It is rising, not in a way you can feel, not in a way that would tip a glass of water on a kitchen table in town, but on a steel cabinet anchored to a basalt outcrop on a peak called the Husband. A green light is blinking once every 30 seconds. The instruments are listening to a breath that was supposed to have stopped years ago. A volcano in Oregon is now rising faster than it has in 25 years of monitoring. As of 2026, the cumulative uplift has hit 30 centimeters, nearly 12 inches of fresh rise across a patch of ground larger than the city of Portland. There are 213,072 Americans living directly inside this regional hazard footprint. Most of them have never heard the word Lahar. Most of them believe the danger ended in 2017 when the headline said the bulge was finished. They were wrong. The system has inhaled again. And the real story isn't the volcano you can see. It's the one you cannot. This is the anatomy of a hidden anomaly. This is AstroWatch Lab ETE. To understand the anomaly, we must first look at the monolithic icons of the central Oregon skyline. In a nearly perfect line stand the Three Sisters, north, middle, and south. To the casual observer, these are merely postcard-perfect landmarks, the backdrop for a thriving outdoor economy. They represent stability. But in the world of investigative geology, these peaks are not siblings of the same age. They are a progression of increasing volatility. While North and Middle Sister have long since transitioned into a dormant state, South Sister is a different entity entirely. Standing at 10,358 feet, it is the youngest, the tallest, and by any scientific measure, the most dangerous of the three. It is a glacier-capped giant that hasn't seen a major explosive phase in 2 millennia, a fact that has allowed a dangerous sense of complacency to settle over the valley below. Just 15 miles north of the mountain's center sits the town of Sisters, Oregon. It is a community of 3,500 residents built on the banks of Witches Creek. The creek is picturesque, fed by the melting glaciers on South Sister's northern flank. It is the lifeblood of the town, arriving in the center of the business district in a journey of less than 30 miles from the ice to the pavement. There is no smoke. There is no smell of sulfur. There are no visible cracks in the earth to warn the thousands of hikers who cross the Pacific Crest Trail every summer. This is the false safety phase of a geological event. The systems we rely on to keep us safe, the zoning laws, the emergency sirens, the regional maps, are all built on the assumption that the mountain we see is the mountain we have to worry about. But the data tells a different story. Because the heart of this anomaly isn't under the summit. It isn't where the tourists are pointing their cameras. To find the real threat, we have to look 3 miles to the west, into a deep wilderness where the ground has begun to move in a way that defies the consensus of the last decade. An atoll. In the traditional narrative of volcanology, the summit is the star of the show. It is the point of maximum drama, the vent where the earth finally exhales its fury. But the anomaly we are tracking at South Sister defies this conventional geometry. To understand what is happening in the Oregon Cascades, you have to stop looking at the 10,000-foot peaks and start looking at the empty space between them. 3 miles west of the glacier-capped summit of South Sister, nestled in a region of deep, roadless wilderness, the ground is performing a slow, silent insurrection. This is the bulge. It is not a localized crack or a small pit. It is a massive circular deformation of the Earth's crust, stretching 12 miles wide. It is a patch of forest larger than the entire city of Portland that is being physically shoved upward from below. The reason this went unnoticed for so long is simple. The deformation isn't where the volcano is. Because the uplift is offset from the main magmatic plumbing of the sisters' peaks, the usual visual cues were absent. There were no steaming vents at the summit, no charred trees, no sudden melting of the glaciers. There was only the data. To capture this invisible movement, the United States Geological Survey had to look for a vantage point that was close enough to listen, but stable enough to survive. They found it on the Husband, a jagged 524-foot peak located just 1.25 miles from the dead center of the bulge. In October 2001, a field crew helicoptered a continuous GPS receiver and a sensitive seismometer onto this basalt outcrop. For years, the instruments on the Husband recorded a steady, agonizingly slow crawl. But since 2021, the silence has been replaced by a persistent, rhythmic twitching. Small clusters of microquakes, vibrations so faint they are undetectable to anyone standing on the trail, have been erupting at a depth of roughly 4 miles, 7 kilometers, beneath the forest floor. This is the sound of rock failing under extreme pressure. Dr. John Major, the scientist in charge of the Cascades Volcano Observatory, has been clear. This is not a change that a human could detect by standing in the woods. You would feel nothing. You would see only the wind in the hemlocks and the quiet flow of the creeks. The physical mechanism is chillingly simple. Imagine a hand pressing into the underside of a mattress. The hand doesn't need to punch through the fabric to change the shape of the bed. It just needs to push. Deep beneath the Cascades, magma, or perhaps a highly pressurized plume of volcanic gases and hydrothermal fluids, is squeezing up through a complex system of ancient fractures. It hits a structural ceiling about 4 to 5 miles down where it cannot rise any further. Unable to go up, it pools. It spreads sideways, and as it fills this subterranean reservoir, it forces the entire landscape above it to expand. Every time the system CE pulses, the ground 150 miles south of Portland gets a little wider, a little thinner, and a little taller. As of 2026, the cumulative uplift has reached 30 centimeters. That is nearly a foot of fresh vertical rise across a massive 12-mile circle. The mystery isn't just what is moving. It's why the movement has suddenly changed its rhythm. To answer that, we have to look at the timeline the mainstream reports missed. The moments where the system was declared finished, only to prove that the Earth doesn't follow our schedules. To understand why the 2026 data is so alarming, we have to go back to the moment the Earth first broke its silence. History is often written in hindsight, and in the case of the Three Sisters, the official story began years after the physical event had already taken hold. This is the danger of relying on systems that only look backward. The year is 1997. In the deep woods 3 miles west of South Sister, the ground begins to rise. There is no sound. There are no tremors. To any hiker crossing the dome that year, the world felt as it always had, ancient, immovable, and safe. But deep in the crust, the first pulses of magma were already arriving at the $6 to $7 kilometer mark, beginning a slow-motion expansion that no human instrument was yet positioned to see. By the year 2000, the rate of uplift hits its first major peak, 5 centimeters per year. To put that into perspective, that is the speed at which a human fingernail grows. Imagine an entire circle of forest, 12 miles wide, rising at the speed of a fingernail. Across millions of tons of rock, that is a staggering amount of energy being injected into the system. Yet, for 4 full years, this massive geological event remained a secret. It wasn't until May 2001 that the invisible threat became visible. USGS analysts, reprocessing older INSAR, interferometric synthetic aperture radar data from European satellites, found something that didn't belong. They discovered 10 centimeters of uplift that had already silently accumulated over the previous 4 years. The response was immediate but contained. A field crew helicoptered a continuous GPS receiver and a seismometer onto the summit of the husband. They were playing catch-up with a mountain that had already been moving for nearly 1,500 days before the first alarm was ever tripped. For the next decade and a half, the system appeared to be stabilizing. The frantic pulse of the late 90s was fading. By 2017, the rate had crashed to just half a centimeter a year. To the scientific community, the South Sister Bulge was a closed case. The consensus paper was being written. Major media outlets declared the event finished, describing it as a failed intrusion, where the magma had cooled and stalled before it could ever reach the surface. This is the moment of false safety. This is the point where the public turns its attention elsewhere, confident that the experts have the situation under control. We were told the mountain had gone back to sleep. We were told the threat was a relic of the past. But the Earth does not read consensus papers. And in the summer of 2020, as the world was distracted by a global crisis, a satellite 430 miles, 690 kilometers overhead caught the ground west of South Sister doing the one thing no one expected. It inhaled again. After 20 years of slowing down, the rate didn't just stop. It reversed. Between 2020 and 2021, the ground surged upward by 2.2 centimeters in just 14 months. The finished volcano was wide awake, and this time, the rules of the previous 25 years were about to be rewritten. In the world of investigative meteorology, we often talk about lag time, the gap between a physical event and our ability to process it. By 2017, the scientific consensus had declared the South Sister anomaly a failed intrusion. The rate of uplift had dropped to a negligible half centimeter per year, and the story was moved to the archives. But while the public turned its attention elsewhere, the Earth was merely preparing for its next phase. The year 2020 was a turning point for the planet in many ways, but in the deep wilderness of Central Oregon, it marked a return to volatility. A satellite drifting 430 miles, 690 kilometers overhead, equipped with the latest INSAR technology, recorded a sudden, sharp reversal in the data. The ground wasn't just moving, it was inhaling again. Between the summer of 2020 and August 2021, the Earth 3 miles west of South Sister surged upward by 2.2 centimeters in just 14 months. For a system that had spent 20 years slowing down, this wasn't just a minor twitch, it was a systemic restart. By early 2022, another half centimeter was stacked on top. As we stand here in 2026, the data has reached a threshold that can no longer be ignored. The cumulative uplift now sits at 30 centimeters, nearly 12 inches of fresh vertical rise. To the human eye, a foot of movement spread over several years might seem trivial. But when you apply that measurement to a patch of ground 12 miles wide, you are looking at a geological force of nature that is physically displacing millions of tons of volcanic rock and forest. To visualize the scale, the area of deformation is now larger than the entire city of Portland. Imagine every street, every building, and every park in a major American city being lifted a foot into the air by an invisible hand. That is the reality currently unfolding in the Oregon Cascades. This is where the false sense of safety collapses. Dr. John Major, the scientist in charge of the Cascades Volcano Observatory, has stated on the record that this process has likely been going on for a much longer time than our records suggest. We simply never had the technology to see it until now. This is a critical insight for our plasma pulse community. We are not just watching a volcano, we are watching the limits of our own monitoring systems. The models that predicted a permanent shutdown in 2017 were based on a snapshot of history. They didn't account for a system that breathes on a decadal scale, a system that can stall for 15 years and then quietly resume its expansion with renewed vigor. The questions for those living in the regional hazard footprint, the 213,072 people in Deschutes County and beyond, are stacking up. Why did the bulge restart in 2020? The exact year the rate was supposed to hit zero? And more importantly, what does it mean for the structural integrity of the glaciers sitting directly above this rising mass? To find the answer, we have to go deeper than the surface. We have to look at the mechanism of the volcano you cannot see, the hidden fracture system at 6 kilometers depth that is bypassing the main summit entirely. When we look at a map of the Pacific Northwest, we see the Cascades as a series of isolated icons: Mount Hood, Mount Rainier, South Sister. We view them as vertical chimneys, pipes that lead directly from the deep mantle to the sky. But the anomaly currently unfolding 150 miles south of Portland is teaching us that the most dangerous part of a volcanic system is often the part that never reaches the surface. To understand the 30-centimeter uplift, we have to look at the volcano you cannot see, the source of the deformation. The engine driving the 12-mile wide bulge is located at a depth of $6 to $7 kilometers, $4 to $5 miles. At this depth, the pressure of the overlying rock is immense, yet something is pushing back with enough force to displace the crust of a continent. The mechanism in physical verbs is this: magma, or perhaps a highly pressurized plume of hydrothermal fluids and volcanic gases, is squeezing up through a complex fracture system from much deeper in the earth. It is searching for the path of least resistance. However, at the 6-kilometer mark, it hits a structural layer, a horizontal boundary where it can no longer rise vertically. It cannot go up, so it spreads sideways. It pools into what geologists call a sill, a horizontal sheet of magma that acts like a hydraulic jack. As this reservoir fills and spreads, it pushes the rock above it upward, exactly like a hand pressing into the underside of a mattress. This is why the deformation is so broad, covering an area larger than Portland, yet so subtle that no human standing on the Pacific Crest Trail could ever detect it. Dr. John Major, the scientist in charge of the USGS Cascades Volcano Observatory, has been remarkably candid about this invisible process. He stated on the record, "This is not the kind of change in the surface of the ground that you and I would stand out there and detect at all. It is a silent accumulation of potential energy, but here is the detail buried in the data that changes the stakes for the entire region." The Three Sisters Bulge is one of only 2 known active uplifts in the entire Cascade Range. It is part of a system that the United States rates as one of 18 very high-threat volcanoes. And yet, the activity isn't happening at the summit of South Sister. It is happening in the empty space 3 miles to the west. This reveals a hidden reality of the Cascades. The mountain you see is just the exhaust pipe of a much larger, more distributed system. The bulge isn't a sign that South Sister is about to blow its top in a Hollywood-style eruption. It is a sign that a new vent could be forming, a hidden system that could bypass the main peak entirely and emerge in the middle of the forest where no one is looking. However, as we dive deeper into the data, we find a twist that the mainstream headlines almost always miss. In our obsession with magma and lava, we have overlooked the most immediate threat to the 213,000 people living in the shadow of these peaks. Because the real hazard at South Sister does not require an eruption at all. The most critical danger is not made of fire, it is made of ice and rock. For decades, the public imagination has been captured by the image of a Hollywood eruption, rivers of molten lava and towering plumes of fire. We wait for the big one, the cataclysmic blast that mirrors Mount St. Helens in 1980. But for the 213,000 residents of the Deschutes County corridor, the most immediate threat isn't made of fire. It is made of water, ice, and gravity. To understand the true vulnerability of this region, we have to look at the terminology of disaster. In the opening of this briefing, we noted that most residents have never heard the word Lahar. It is an Indonesian term, now a standard in global volcanology, describing a violent mud flow or debris flow composed of a slurry of pyroclastic material, rocky debris, and water. Think of it as a wall of wet concrete moving at highway speeds, carrying boulders the size of houses. South Sister is a glaciated peak. It carries 5 major glaciers on its flanks, each acting as a massive frozen reservoir. But these glaciers are not stable. They are often held in place by moraine dams, unstable ridges of loose rock and soil left behind as the ice retreats. These are not engineered dams of reinforced concrete. They are dams made of rocks sitting directly above tens of thousands of people. The data reveals a pattern that predates the current magmatic pulse. 5 separate times in the last century, these glacial moraine dams have failed without warning, sending walls of mud and boulders screaming down the mountain's flanks. We saw it at Collier Lake in the early 1940s. We saw a devastating flash flood on October 7, 1966, and perhaps most notably, the Diller Lake failure in 1970. None of these events required an eruption. They happened because of simple structural failure, and this is where our 30-centimeter bulge becomes a secondary, terrifying catalyst. When the ground beneath a massive, unstable reservoir of ice and rock begins to inhale, rising nearly a foot over a decade, the structural geometry of those moraine dams changes. The uplift isn't just a vertical movement, it's a tilting of the landscape. It introduces new stress points into ancient, loose rock. It shifts the balance of a system that is already on the verge of collapse. While we watch the satellites for signs of magma reaching the surface, we are ignoring the fact that the trigger for a regional catastrophe is already sitting on the mountain's doorstep, waiting for the slightest nudge. The history books tell us that none of the 20th century Lahars reached the town of Sisters. They stalled in the wilderness, miles from the nearest school. But those were smaller events, born in a time when the ground was stable. The next one might not be so contained. This is the invisible disaster, the threat that doesn't make the evening news because it hasn't happened yet. But when it does, the timeline of human reaction will be stripped to its absolute limit. Because once a Lahar begins, the clock doesn't count in days. It counts in minutes. And for the people of Sisters, those minutes are fewer than you think. In the world of disaster mitigation, there's a concept known as lead time, the buffer between the first detection of an event and its arrival at a population center. For a hurricane, that buffer is measured in days. For a winter storm, it is measured in hours. But according to United States Geological Survey Lahar models, the town of Sisters operates on a different, far more brutal mathematical reality. Between the moment a glacier-fed lake fails and the moment the front of the wave hits the city limits, the town has between 30 and 60 minutes. This is the 30-minute problem. To understand why this is a nightmare for emergency management, we must run a real-time simulation based on the existing USGS data. The initiation, a moraine dam weakened by the constant 30-centimeter tilting of the ground and decades of freeze-thaw cycles, finally fails. This doesn't require a massive earthquake or a volcanic explosion. It is a structural collapse. Millions of gallons of water and ice begin to move. In town, everything is silent. Nobody is watching the glacier. The transformation. As the water rushes down the steep volcanic slopes, it picks up everything in its path: ancient trees, boulders the size of cars, and the very soil of the mountain. It is no longer water. It has become a lahar, a slurry with the density of wet concrete moving at highway speeds. The energy being generated is equivalent to a freight train that never ends. The acceleration. The lahar enters the narrowest parts of the drainage. The constricted topography acts as a funnel, increasing the height of the wave. It has now covered 15 miles. In the town of Sisters, the first subtle sign might appear: a slight vibration in the ground, or the water in Witches Creek suddenly turning black and thick with sediment. But for the 3,500 residents, there has still been no official siren. The impact. Picture this. A waitress on a Tuesday morning in downtown Sisters hears a sound she has never heard, a low-frequency roar like 1,000 jet engines muffled by the earth. By the time she reaches the door to see what it is, the front of the wave is already crossing the city limits. In less than 30 miles of travel, the mountain has arrived in the center of the business district. This is the part of the data that nobody likes to talk about. You cannot evacuate a town of 3,500 people in 30 minutes when the trigger is a glacier that nobody is watching. There is no time for door-to-door checks. There is no time for a coordinated traffic plan. The 30-minute problem reveals the absolute fragility of our modern infrastructure. We have built our lives on the assumption of a slow reveal, but the physics of a Lahar doesn't care about our schedules. And as we look at the data from 2026, we realize that Sisters is only the first layer of this regional cascade. To see the true scale of the risk, we have to look past the town, toward the city of Bend, and into the very skies above the Pacific Northwest. When we discuss geological anomalies, we often fall into the trap of thinking locally. We focus on the town at the foot of the mountain or the hikers on the trail. But the 30-centimeter surge west of South Sister is not a local event. It is a systemic disruption that ripples outward through 5 distinct levels of escalation. To understand the true stakes of the 2026 data, we must look at the cascade scale, a chain reaction where a single geological pulse in the wilderness can paralyze an entire region of the United States. Level 1, the wilderness. The Pacific Crest Trail crosses the dome of the bulge directly. At this moment, any hiker standing in that 12-mile circle of forest is occupying the kill zone of a potential phreatic explosion. This is a steam blast, similar to the one that tore through Yellowstone's Biscuit Basin in July of 2024. It requires no magma to reach the surface, only the heating of groundwater by the intrusion at 6 kilometers depth. In this scenario, the failure mode is instantaneous, happening exactly where people stand, with 0 lead time. Level 2, the town. As we established, the town of Sisters and its 3,500 residents are positioned downstream of an unstable glacier. A Lahar triggered by either an eruption or a simple structural failure would arrive in less than 30 to 60 minutes. Level 3, the city. This is where the scale of the disaster shifts from a local tragedy to a regional crisis. 23 miles east of the bulge sits Bend, Oregon, a city with 109,389 people inside its urban growth boundary. While Bend is largely protected from Lahars by topography, it is directly downwind of the volcano's explosive potential. Models show that a Rock Mesa scale explosive phase, an event with a 2,000-year historical analog in this specific system, could deposit 1 to 2 inches of abrasive volcanic glass over the city. This is not ash in the sense of burnt wood. It is pulverized rock and glass. It kills small engine vehicles instantly. It shorts out heating and cooling systems. It contaminates the Bridge Creek water supply, the primary source for the city's residents. It would close Roberts Field, the regional airport located 12 miles north of Bend, for weeks, severing the area's primary link for emergency supplies. Level 4, the county. There are now 213,072 residents in Deschutes County living under the regional hazard footprint. This is the fastest growing population in Oregon this decade. The infrastructure, the roads, the hospitals, the power lines, was not designed to handle a mass evacuation or a long-term sheltering-in-place scenario for a population of this size. Level 5, the global corridor. Finally, we look at the sky. The Pacific Northwest Aviation Corridor connecting Seattle, Portland, and San Francisco runs directly over the Cascades. In 1980, the Mount St. Helens eruption shut down this corridor for weeks. A South Sister explosive phase would do it again, but this time, the stakes are exponentially higher. We are now dealing with over 4 times the air traffic compared to 1980. A single pulse of ash from a finished volcano could ground thousands of flights, disrupting global logistics and the movement of millions of people across the western seaboard. The 30 centimeters of uplift we are tracking in 2026 is the first domino in this sequence. The question is no longer if the ground is moving, but how many of these systems are prepared to fail when the mountain finally decides to exhale. What happens next is the part no one can answer. We have the data, we have the satellites, and we have the history. But we are dealing with a geological intelligence that operates on a timeline far beyond our own. The $30 centimeters of uplift we see today could be the prologue to a cataclysm, or it could be a pulse that simply fades back into the silence of the Earth. In the world of investigative meteorology and geology, we look for patterns, but the South Sister Bulge has spent the last $25 years defying them. The uplift could stall again, just as the consensus predicted in $2017, only to resume in another $15 years. There is also the possibility that the fluid plume at $6 kilometers depth is not magma at all, but highly pressurized hot water and gas. In that scenario, the failure mode would likely be a phreatic explosion, a sudden steam blast that could happen exactly where a hiker is standing, without any warning from the deeper magmatic system, or the system could keep refilling. The geological record provides a haunting analog. $2,000 years ago, a similar sequence of events left a 5-mile fissure of black glass on the southeast flank of South Sister, the Devil's Chain. That single event produced $20 separate domes and lava flows in a single eruptive sequence. Dr. John Major has stated that we would likely see more signs before such an event: more frequent earthquakes, faster uplift, and the venting of volcanic gases. But he has also admitted that this process has probably been going on for a long time, and we simply never had the instruments to see it until now. This brings us to the ultimate question: which sentence is the real one? Why did the bulge restart in $2020, the exact year the models predicted the rate would hit zero? And what does it mean for our accuracy that the closest seismic instrument to the deformation center, the one bolted to the husband, is itself rising half a centimeter a year toward the very satellites it is talking to? We are measuring a moving target from a moving platform. As we conclude this debrief, we return to the town of Sisters. The 30-minute problem remains the most pressing reality for the 213,000 people in this corridor. How do you evacuate a town in half an hour when the trigger is a glacier that nobody is watching? The thing sitting on Ben's doorstep is not a movie volcano here with predictable eruptions and slow-moving lava. It is a complex, glacier-fed system with a dam made of rocks, sitting above a population that is growing faster than its ability to respond. Right now, on a basalt outcrop in the deep wilderness, a green light is blinking once every $30 seconds. The ground is still rising, the instruments are still listening, and the volcano that everyone said was finished is breathing in. This has been a AstroWatch Lab Nightly Debrief. Stay vigilant, stay informed, and watch the ground.